right, hello students. So we're starting our quadratics unit, and I really like to start this quadratics unit just by comparing and contrasting our new function of quadratics with the other two functions we've been studying all year, which are linear and exponential functions. And so as you're looking through this, some of this should be familiar, and then some of it should be new. And so I'll go over all of this briefly, and please ask questions or comment if you think I did anything wrong or if there's anything that doesn't make sense. So on a linear relationship, what you should notice is that as you move from one y value to the next, there's a constant thing that's happening. On this first table, we're always just doing plus 3, plus 3, plus 3. And on the second table, we're always just doing minus 7, minus 7, minus 7. And so that's the big idea, is just that linear functions, or you could say linear patterns, or you could say linear tables, you could say linear equations. But you can say linear functions change by adding or subtracting a constant. The same number gets added or subtracted every time. Then if you look at exponential, we just did this whole unit, so this should be pretty familiar. Notice that what we did to go from one y value to the next is dividing by 2, or I could have said multiplying by 1/2. And then over on the second table, it's not division, it's multiplication by 4. I guess I could have said it's dividing by 1/4, which is the same as multiplying by 4. But that's not the important thing. The important thing is that exponential tables, exponential functions, there we go, close enough. Exponential functions change by multiplying or dividing a constant. And so up until this point, we've looked at things that all change by a constant. And it's either adding or subtracting a constant with linear, or multiplying or dividing a constant for an exponential function. Now we have a new thing called a quadratic function, and the quadratic relationship is a little bit different. If I start with 0 here, there's no number that I can multiply by to make it turn into 1. So I already know it's not exponential, it's not a multiplication pattern, it's not a division pattern. So then I start thinking about adding and subtracting. And I can say, okay, plus 1, plus 3, plus 5. Well, it's not linear either because it's not adding the same amount every time, it's adding a different amount. Same sort of thing if I look at the other table here. I see this goes up by 6, up by 2, and it goes down by 2. And so it's a little bit confusing what's going on with a quadratic relationship. It's not multiplying, and it's not adding or subtracting the same amount every time. But there's a nice pattern that shows up when you look at the rate of change of those rate of changes. So how do I get from a plus 1 to a plus 3? By adding 2. How do I get from a plus 3 to a plus 5? By adding 2. I could predict that the next change is going to be plus 7 because that would continue this second change pattern of plus 2. Same sort of idea here. When I look at the change to get from plus 6 to plus 2, that went down by 4. When I look at the change from plus 2 to minus 2, that went down by 4. So I can predict that the next change would be minus 6, and the one after that would be minus 10. And so it turns out that a quadratic pattern is new. It doesn't add the same amount every time. It doesn't multiply the same amount every time. But the changes of a quadratic pattern are linear. If you focus just on 1, 3, 5, 7, that's a linear pattern. If you focus on 6, 2, -2, -6, -10, that's a linear pattern. And so I had a typo here. This should have said quadratic. But like I mentioned, linear changes by plus or minus a constant. That's linear. Exponential changes by multiplying or dividing the constant. But quadratic changes at a linear rate. And that's different. When we stop looking at it just as numbers, we start seeing the picture here. And you can see the same sort of thing I was talking about, that a linear pattern just goes plus a couple boxes, over a few boxes, plus boxes, over, plus boxes, over, always adding the same number of boxes to move to the right. Exponential, it's a little harder, I think, to see exactly why, but the height is always multiplying. So this is like 2 boxes tall, and then it's twice as tall, and then it's even twice as tall as that. So the height is always multiplying by the same amount every time you take a step to the right. Quadratic, however, changes at a linear rate. So that's why we see here it goes down by like 4 boxes, then it goes down by like 2 boxes, then that's more than that. What does it do? It goes from 9 down to 5. So that's down 4 boxes. Then it goes down by 3 boxes. Then it goes down by 2 boxes. Then it goes down by 1 box. Then it's flat. Then it goes up 1 box, up 3 boxes, up 5 boxes. And so the rate of change itself is a linear pattern. Now, that's a hard way to think about it. When you have a picture, it's pretty simple to see that linear just means it's a straight line. That's why the word line is in it. Exponential means it's that nice shape that we've seen a bunch of. And quadratic means it's a smiley face. We will also see quadratic equations that look like frowny faces. Moving along, linear equations, exponential equations, and quadratic equations. What you should notice about linear equations is that there are no exponents. What you should notice about exponential equations is that x is the exponent. And what you should notice about quadratic equations is that 2 is the exponent. And that's the difference between those 3 different types of equations. So then, finishing up here, we see some tile patterns, and we can see also that we have linear, exponential, or quadratic. Here, this is linear because it's adding a plus 2 boxes every time. Here, this is exponential because the number of black triangles is multiplying by 3 every time. And here, this is quadratic because it's not adding the same amount every time, but it's adding a linear pattern of boxes every time. So, for example, this is going plus 5, and then this is going plus 9, and you could draw even the next one. So, thanks for watching. Please comment if you've got any questions or concerns.